All right, Unit 9, Forces in Motion, Notes for Practice Problems. We're going to go through these pretty quickly. There's only 6 of them. Number 1 says, a physical science textbook has a mass of 2.2 kilograms. What is its weight on the Earth? Well, we have to write down the first piece of information that we have, which is 2.2 kilograms, and that's our mass. All right, we are looking for weight. And the equation that we learned, weight is actually a force unit. So it can be calculated by doing mass times acceleration. Mass times acceleration due to gravity. So we know gravity as well. Gravity is a constant on Earth. It's 9.8 meters per second squared. Okay, so then all we have to do is plug in the values here. Weight here is equal to mass of 2.2 kilograms times 9.8 meters per second squared, and that gives us the weight. So the weight is equal to, if we do 2.2 times 9.8 meters per second squared, we get a value of 21.56. And then what's the unit? Well, the unit is kilograms times meters per second squared, but a unit of force is actually newtons. Okay, so it's a weight of 21.56 newtons. All right, so what is the weight on Mars? So how does that book compare on Mars? Well, we still have the same mass, so this is number 2. 2.2 kilograms. And then we don't know what the weight is, but we do know what the gravity is. That was given to us in the problem. 3.7 meters per second squared. So I'm going to do weight equals mass times gravity. Weight is equal to 2.2 times 3.7. So if I do 2.2 times 3.7 in my calculator, I get a weight that equals 8.14 newtons. All right, so you see how much lighter someone might feel on Mars versus on Earth. And then finally, number 3 says, if the textbook weighs 19.6 newtons on Venus, what is the strength of gravity on Venus? Okay, so now we're actually working backwards. We have the weight, that's 19.6 newtons, and then we still have the mass. The mass was 2.2 kilograms. And then I'm actually going to hide here for a second because you actually can't see this part. There we go. And then we're looking for gravity. What is gravity? Okay, so we have to kind of rearrange this equation to solve for gravity. So gravity is going to equal the weight divided by the mass. Okay. So we found the weight to be, gravity is equal to 19.6 newtons divided by 2.2 kilograms. So if I did 19.6 divided by 2.2 in the calculator, I get a gravitational field of, or gravitational acceleration of 8.9 meters per second squared. All right. You might have not known this, but Venus is actually the planet that is very close to Earth's size. It's the closest to Earth's size. So you can actually see that the gravities aren't that much far off. It's certainly not like Mars and Earth, where like their gravities are very far off. 3.7 and 9.8 are very far off, but 8.9 and 9.8, they're not that far off. Number 4 says, of all the planets in our solar system, Jupiter has the greatest gravitational strength. If a 0.5 kilogram pair of running shoes would weigh 11.55 newtons on Jupiter, what is the strength of gravity there? Okay, so we've got some pieces of information. We have 0.5 kilograms, and then 11.55 newtons. This is going to be a measurement of mass, and then this is a measurement of force, but in this case, we're measuring weight. And then we're looking for gravity. Okay, so we don't know what gravity is. The equation that we're working with is weight is equal to mass times the acceleration due to gravity. So if we're looking for the gravity, it's going to be the weight divided by the mass again, like just like number 3. So gravity is going to be 11.55 divided by 0.5. So let's find out what the gravity is going to be there. Okay, so gravity on Jupiter is actually much higher. It's 23.1 newtons. All right, so that's number 4. Number 5 says a small car weighs what is it? 10,168.25 newtons. What is its mass? Okay, so we know that weight is equal to gravity times mass, or mass times gravity, doesn't matter. And we're looking for mass. So mass is going to equal weight divided by gravity. So in that case, mass is going to equal the weight of 10,168.25 newtons divided by 9.8. So we're looking for the mass. So 10,168.25 divided by 9.8 gives us a mass of 1,030, we'll round, 1,038 kilograms. I got 37.57. So that's about 2,300 pounds or so, 2,400 pounds, somewhere between that range. Okay, number 6, last problem. A locomotive's mass is 18,181.81 kilograms. What is its weight? Okay, so we have the mass now, and we have weight is equal to mass times gravity. And we're assuming Earth's gravity, so weight is equal to 18181.81 times 9.8. Okay, so I'm going to put that into a calculator. 18181.81 times 9.8. I get a weight of 178,181.74 newtons, if I want to be really specific, but I don't need to be that specific. I could have just rounded to 178 182 newtons. You could that answer would have been fine. All right, so that concludes the practice problems for Unit 9, Notes 4.